In today's video, we're looking at Young's modulus of a wire. So this is a materials experiment to look at the stress strain on a length of wire. We do ours set up across several benches. So we've pushed 4 benches together and we have put a pulley on one end, and at the far end we have clamped between a couple of blocks one end of the wire to the table. We're going to take a diameter measurement of the wire to find its radius at 3 or 4 places along the wire. We've fixed an S-hook on this end. Little bridge-shaped structures are to stop the wire peeling back so much if it snaps. We're wearing eye protection. We've got a ruler blue tack to the bench so it's held in place. And we've put a little marker on the wire, a little piece of tape, and we're using one end of that as our measuring point. We're taking an initial measurement of the length of the wire under test from the blocks where it's clamped at that end to the edge of the marker that we are taking our extension measurements to. And to do that, we'll probably put a few small masses on this end just to tension the wire. So less than 100 grams to get a bit of tension in the wire. Once we've taken a 0 reading on the ruler and our initial reading, we're going to add masses incrementally. We've got an S-hook on this end and we've got a bucket with some foam in it in case the wire snaps and the masses fall to the floor. So adding a mass, taking a measurement of any extension, carefully adding another mass, recording any extension, and continuing adding mass, recording mass and extension. The masses, of course, we can work out from the mass the force being applied using normal amount for gravity, and continue doing that until we either fully extend the wire and the masses hit the floor, we move the bucket out of the way, or the wire snaps. We don't get very much extension here to start with, it's going a little bit, a few millimeters. But the reason for our long length of wire under test is that it will be so many millimeters extension per metre. If we're starting off with at least 4 metres and we're getting 1 millimetre extension per metre, it's easier to measure 4 millimetres more accurately than the 1 millimetre. We're still only getting millimetres of extension. Oh, starting to creep a little bit now. Students will have been doing this lesson that was just finished and recording their measurements. I've just left one set up so that I can video it. And now it's starting to move. You can probably see that on camera that it's moving quite a lot. We've got up to about 1.2 kilograms. I think this is probably 0.28 millimetre diameter copper wire. Let's try and position this so we can see the marker move when I put the next one on. Sorry about that, a bit shaky. So another 100 gram mass. and you can see the extension. It's still creeping a little bit. I'm going to move the bucket out of the way because we're nearly at the floor, and put a final one on there. And you can see at the moment we're getting creep there. It's only extended and then it's still moving a little bit, creeping along as it extends. It'll stop in a couple of centimetres because it's going to reach the floor. So that's Young's modulus for a wire. This is our method of doing it. There's methods hanging a length of wire from the ceiling and adding mass, a bit like the Hooke's law experiment, and using a vernier scale to make measurements. You can print labels with a vernier scale on them to use against the ruler if you'd wanted to get them to use a vernier with this method. But as you can see, if you choose the correct diameter wire, you can get some quite good results.